Hello everyone. In this video of CoppeliaSim, I want to show you how to import a mesh which you can export from any CAD software, right? Or let's say you bought a new robot and they gave you the CAD model or the STL file, the mesh. So you bring in the mesh and you can then convert it to an actual robot. So while this one is just a bunch of triangles, right, and a bunch of vertices, you cannot do anything with this one. This one is the robot version of that. So look here, this one clearly this one is clearly working. So I want to show you how to go from here to here, okay? And this is the robot with the tree that I made. So let's talk about it. Now, but before I get into the details of that, I want to talk a little bit about these four shapes that you have not seen in my video so far, because so far I only showed you primitive shapes, right? And you can have primitive compound shapes, which is a group of primitive shapes. So let's say you have a cube and a cylinder merged together, right, as a primitive shape. So there are also simple compound shapes, convex shapes, and compound convex shapes. So the simple shape is basically a mesh file that you bring in, but it has only one color and visual attributes. And these are not the things that you want to do dynamic collision response with. Why? Because typically when you bring a mesh file, it has so many vertices and points and triangles, so it can make your calculations unstable and be very slow. When you have a simple shape like a cube, it's just defined by a few parameters, but mesh is defined by lots of points and triangles. So meshes in general, unless you make them very simple, are not the best way to go. The best way to do any calculation for collision, for motion, and so on are primitive shapes. But sometimes primitive shapes are not ideal to show the shape of a robot. You really need to show some geometry. So you bring in a mesh. But now you want to convert that mesh into something simpler. Now, if you have several mesh files that each one of them has its own color or visual attribute, you're going to have a compound shape. So these are several meshes, right? Or one mesh that is made of sub-meshes with different colors and attributes. Then you can convert any mesh into a convex hull, which is basically the smallest polyhedron that completely contains your mesh. And this is a much simpler shape, okay, compared to the mesh. Again, if the shape is not a convex shape, this one is going to be quite different than the original one, and I'll show you. And then you can merge them against several convex hulls, meshes with different shapes and attributes, and you get a compound convex shape. So here you're going to see the simple shape and the convex shape. I'm going to show you these two. Again, you can combine them and make a compound one, but that's not what I'm about to show. So let me go here. So this is the mesh that I brought in. Where do I bring it in? So if you go to File and then you go to Import and go to Mesh, you see that CoppeliaSim installation folder. Under this folder, CoppeliaSim edu CAD files, there are some STL files or OBJ or something. So this is this guy here. Look. You bring it in and said, what is your texture maximum resolution? Do you want to auto scale it and everything? So you bring it in and there we go. Look. So what I brought in is this guy here, right? You see, that's this one. Now, how many triangles does this guy have? How many vertices does this guy have? So if you double click on this, right, and then go to geometry, here you see the shape window, and you see that it has 3,300 triangles and about 2,000 vertices. Okay, so such a thing, although it's not really big, but it can make your simulations slow. So one of the first things you can do, if you like, you can do what we call a mesh decimation. You reduce the number of points So you can go to modules and then go to geometry mesh. And here are a bunch of mesh operations that you can do. You see, you can do decimation, you can create a convex hull, you can basically do isometric scaling, you can do mesh union, mesh divide, mesh intersection. There are all sorts of mesh operations that you can do. So let's say right now I want to reduce the number of points and triangles. So I say I want a mesh decimation, and it says by which percent. So let's say I want to reduce it to 50% of what it was. And you can include all model shapes are hidden and adopt the color. Look. So now if you look at it, this new one that is right on the top of previous one, let me move it away so you can see that. This one is the decimated version of that. And you can clearly see that the meshes are quite a bit more rough compared to this side here. These are smoother, these are rougher, but still the geometry is preserved. I mean, these kind of more smooth arcs are now kind of more jagged and pointy, but clearly the geometry is still preserved. But if you go quite a bit less, you just go to 10% and means reduce the number of triangles to 10% of what it was. That is not gonna keep the shape. You see, now I'm down to 1600 instead of it was about 4,000. Now I'm about half of that. Again, if I go to 10%, this is gonna look very bad. So that's one of the things you can do, reduce the counts, okay? That's one of the things. What else can you do? So there are lots of things you can do. You can get rid of some portions of the shape that are not super important. For instance, here, if I want to tell you this portion, let me show you. This portion that you have this guy here, this head here, let me show you. This head here and this arm here, these are one single object. If you want, you can basically do some local mesh edit, and instead of this non-convex shape, you can make it a convex shape if you want. Okay? Yeah? So right now it's all one single mesh. But next I'm going to show you how to break it into individual meshes or individual mesh components that are connected together, and then you can merge them back again and you can make convex hull. But you see here, this portion of the geometry, this kind of cut here, that doesn't play any role. So you can make it much simpler. Or another one is here, you can see, for instance, this portion that this member and this end of the gripper, these two are connected. If I just make it a convex hull, that can do the job as well. So you can always make your mesh as simple as possible. So let me get rid of this for a second, and let's focus on this one here. So I brought this decimated mesh, and now it is time to break it down into smaller components. So we go back to modules, we go back to mesh, and now one of the things you can do is to divide, right? So you can say mesh subdivide, right? Or another thing you can do is better is this one. Go to redundant and then go to edit and then go to shape grouping merging and then use the divide. This is the better one. Look. So look, I broke it down into what? I broke it down into all of these guys. Some of them you see they are simple meshes, some of them are convex hulls like that. So some of them are convex hulls, some of them are not, right? So let's say I get this. Now, if I want to get my link number 1, this red member, what should I do? If you look here, we can see that the red member is made of a few components. What are they? That's one of them, this plate here. This curved member in the back. There is another plate here. There is this curved member, there is this member, and there is this member. They are all really one single object if you want. Or you can add this guys to this blue member, okay? That's up to you. So right now, let's say I want to merge this red one. and sorry, this one and this one and this one and this one. These four, these are one single member, huh? So I highlight all four of them, and then I go to edit, to grouping, and then say what? Merge. Once I merge them, now look, these are all one single member, and I can double click on them and I can call them what? For instance, link one. Now that I got link one, I can double click on this and I can go to color, for instance, and set the color of these guys to red. You see that? So now that is my member number one. Okay, just like that, I got this merged mesh. Then I can go to this guy here, and then you can add it to this one and these two guys and make it another member, right? But you know that you have these two vertical planes too, so you have to pick those, align with this, this one, and this one, as well as this cylinder. So let's say these are all one member. So now again, I go edit, and then I go ahead and group them together. You see, now I got all of this one single member, and I'm gonna go ahead and call it link number two, right? So now link number two is all of this. And again, you see here, you see that is a compound simple shape, and I can double click on it, and I can go ahead and edit the appearance of that, right? So, and I can do it component by component, or I can, let's see if I can pick all of them. Probably not, because it's a compound one, so you have to use this different colors for each one of them. So let's say I pick all of them to be blue, for instance, right? So I this blue, and then I'm gonna repeat it for the other ones, and I make them blue as well. Let me do it right now. Just to show you it's really a compound shape, I picked a little bit different color for this portion of it. Okay, so this part is gonna have two different colors, and you can see that here, right? So there we go. I have one now called link one, and then I have another one called link two, yeah? And I can keep doing that and define the other members. But let me show you one of them that is useful, and that is convex hull. Let me show you. If a shape is a convex shape, or you can define it as a convex, which makes your calculations a lot simpler, you can do something like this. So let me show you. I pick this portion and this portion, right? And I basically merge them together. And this one, I call it link 3, but since I already have a link 3, I call this link 3 new maybe, so it's not the same name. Now, if you look at this link 3 new, let me first change the color of it briefly. And I want to show you what you can do. So this shape is a very simple shape, and this curvature here, these fillets, these don't matter at all. Actually, you have to add this guy to them as well. Now, let me show you something interesting. So if I add this to this guy here, what will happen to the color of that? So I pick this link 3 new, and I go ahead and merge them together. Look at the color of that head. You see, it immediately turned into green as well, because that belongs to the rest of it. So now the whole thing is green. And as I said, these cuts, these fillets, none of them plays any important role in the kinematics of this object. So what I can do, I can pick this link 3 new, I go to module, I go to mesh, and say, give me the convex hull of this. And generate one convex hull for the whole thing. There we go. Look. So now you get this beautiful one instead of that one. And if you don't need this, you can double click on it, and you can go ahead and hide it. Right? So now that link 3 new does not exist. Instead, you have this beautiful one. You see how good it is, right? And these are, of course, part of it. But if you just wanted to do it this, right, you got your convex hull now. And this convex hull that you have, you can call it link 4 new or anything. Of course, you can give it any color that you like, right? So let's make it like kind of yellowish, like this, right? And then you can do the rest of your computation. So wherever you can do a convex hull, my recommendation is you do that here. And as you can see in this previous version I did, this one here and this one, I made them a convex hole. Now, let me show you how to connect this blue member, which I call link 2, or let me call it link 2 new, because I don't want to have things that exactly shadow each other. I already have link 1 and link 2 here. So if I want to connect link 2 and link 1 with a joint and make one of them rotate about the other one, look, this is what I'm gonna do. And let me get rid of a bunch of things here because it's really on my way. So I just want to show you some of these. I have way too many things here. I don't even need this one. So let's say all I want is link 1 new and link 2 new. I don't even need link 3 new. So if I want to connect these two and make them spin with the joint, this is what I do. So I go ahead and say add and then say a joint, and then I want a revolute one. And then that revolute, the axis of it should go in this direction. So the first thing I do, I'm gonna rotate it, in this case about the x-axis, and rotate it by 90 degrees, or if you want, you can just type in the number. So my software crashed right in the middle of recording the video, so I had to open it and I didn't save it. So what I did, I copied these two links from this robot. I brought them here so I can show you how to make the joint. So sorry for that part. Let's go and add a joint. As I said, I want to add a revolute joint. And the first thing I want to do, I want to rotate this guy about the x-axis, and the angle should be 90 degrees, right? And you can always check it from here. So you see, you make it exactly 90 degrees like that. And then you can place it wherever it should go. In this case, I want to do XZ motion. So I move it, and you can see here. So let's say this is a good place. Now I just go Y. Let's see. So you have to just be patient and place it there properly. I see it was absolutely not in the right place. From my angle, it looks like it is, but definitely it wasn't. So let me first bring it here. Maybe then I go up Z, come here, and then do Y. Now get it out of the part, no Z. So let's see, something like that. Now I just need to go back up in the Z direction, something like this. Okay, so let's say this is the proper location of the joint, and you can resize the joint if you want. You can make it longer, you can make it shorter, you can move it. So I can grab this guy and just move it a little bit in the Y direction so it comes out from the other side, something like this. But remember, you can easily resize a joint. You can just double click on the joint and you can change the length of it or the diameter of it. Okay, so now that I have this, what I need to do is this link 1, this revolute joint should go under link 1, and then link 2 should go under revolute joints like this, make it 3. And now I can go to this revolute joint, go to dynamic properties, and instead of free, I give it a velocity, let's say, or I can give it a position and say, hey, your target angle is to go to 45 degrees, and you want to do it with max velocity of, let's say, 15 degrees per second. So it takes about 3 seconds. You need to give it some max torque so it can carry the load here, right? And the closer they are to the base, you need to add more torque because they carry the torque of anything else here, right? So want to write this, run this simulation, it's not going to work right now because these objects were just mesh. I need to make them dynamic objects, especially this one that is spinning. And by the way, I guess I put the joint in the wrong place. That's definitely in the wrong place. Now the problem is if I move the joint, the rigid body moves, the mesh moves with it, okay? Because they are now a part of, the link to is a part of joint. So what I need to do is first, let me get this back and go ahead and make this set parentless for a second. Let me, I put it in the wrong place. Let me go down in the Z direction and I need to come up here, maybe something like that. Let's see if I can do a little bit better job. There we go. So it should go there, right? And as I said, you can make it longer. Now I want to drop this link to under it. And now, as I said, this link, when you make it from a mesh, you have to make it dynamic. So I need to double click on this, go to the dynamic properties and make sure I make it dynamic. If I need to have collision, I need to also make it respondable. Now, if you want to make a non-convex shape like this respondable, you're going to get a warning. It says, hey, if the shape is not a convex or a primitive shape, then it is not going to be really good for collision. So it's not a good idea to run collision on non-convex shape. But as I said, in order to move it, you definitely need to make it dynamic. Okay, absolutely need to make it dynamic. For this one, if you make it dynamic, the problem is it is going to fall down. So this one, in this case, if you make it dynamic, it is going to fall. So for this one, you want to make it static so it acts like the static base. But if this is your joint one, like the robot is, you see, I put this on a base. So this red one also spins. Okay, if you look at this red one, it has this joint here, this vertical joint. So the red member spins about the black member with this joint, right? But in this case, if all my robot has these 2 degrees, as I said, this one you want to keep it static. And let's go ahead and simulate. Let me slow it down. Did you see that? This one went to 45-degree angle and did it relatively fast, right? If you want to see it better, you can always go ahead and reduce this max velocity. So now it is gonna do it quite a bit slower. And let me put it on this. There we go. You see? Okay. So this is how you create these members and put the joints between them. In this robot, all of these are revolute joints except for the gripper that has a prismatic joint, as you can see here. And this is basically the essence of making a robot from just a bunch of mesh files. Now, once you're done with this robot, you grab this basically base of the robot, right? In this case here, this guy, double click on it and then check it as a model. You say this guy is a model. So now this whole thing will be a model. Okay, and once it's a model, guess what you can do? Let me first save the scene. Once it's a model, now you can basically save the model as. And that's what I did here. I picked this guy, and in my case, I called it the ARM60OF with gripper. So I saved that. What's the good thing about it? The good thing is if I'm here, I can just go ahead and basically I can load the model, right? So I go here and there we go. Look here, I brought the robot I just made. Now it's another robot like anything else, and I can run it and I can do anything that I want. You see? There we go. So you made a model just starting from mesh file. And by the way, if you look under robots, under non-mobile, this is basically this guy here. This is this, we call the 7DOF robot, which includes the gripper. And it's, I guess it's called the redundant robot. So this is this robot here. You see, this is a good job that they did, converted it to a beautiful shape here. So what they did is this part is fixed. This other small disc on it is the rotary one, and this is the color they put on it. And in my next video, I'm going to use this for an inverse kinematics demo. So hopefully this video was useful to you. From now on, just bring any mesh file from your CAD or from the manufacturer of a robot that does not exist in Coppelia. Use this technique, convert it to the robot you want, and you can do any kind of simulation on it. One of the best things you can do here is to make sure the torque that you have on your joints, whether that torque is strong enough to keep the system in place or not. For instance, look here, with these torques that I selected, if I run this, look what happens. Look, the torque here is not enough. Look, it is falling down. You see? It is going into the floor because the torque I placed here at these revolute joints, they are not strong enough to carry all of that weight. Okay? So you can check whether your motors that you pick are strong enough to give you the motion that you want or not. The same goes for a mobile robot. You can see whether they can achieve the speed or the acceleration you want or not, because you know how to now plot the velocity, position, or anything of a mobile robot by adding a dummy and plotting that as I showed you in previous videos. So hopefully this video was useful to you, and I'm gonna see you in the next lecture. Thank you.